tricks, that means permutations and combinations. Combination of digits and permutation of digits. Now, permutation of digits and permutation of objects. It is easy to pursue the permutation of digits because we know how to count the numbers. For example, if there are 4 digits, 1, 2, 3 and 4. Now form 3 digits number, form 4 digit numbers using all the 4 digits. Then you will write starting if in the increasing order 1234. Next number 1243 in the increasing order. If not, if we take in the decreasing order 4321. Either we may list in the increasing order or we may list in the decreasing order. If there are objects, somewhat we will be confused. That's why for the elementary things, Bhaskaracharya deals with only elementary things. He has dealt with the combination of digits or permutation of digits. Now, coming to the first verse number 261. Yeah.
अनन्तमेकादिशयाङ्कघातः संख्याविभेदानियतैस्युरङ्कैः प्रत्योऽङ्गमित्याङ्कसमासेषु युक्तो विधिसंयुतिः स्यात्.
Now here there is a technical term, Jaya. Here there is a technical term called Jaya. Jaya is the series which have for the first term and common difference 1. That the series which have 1 as the first term and the common difference also 1. So what should be the next term? 2. Next term 3, 4, 5, etc. up to n. So Jaya is the arithmetic series in which the first term and common difference both are 1. Sthananta, anta means last one. In the permutation of digits, if there are n terms, nth term will be the last term. Sthanantam eka adi chaya. Eka adi eka chaya. Ekadi chaya anka ghataha, that is product. Product of the arithmetic series in which the first term is 1 and the common difference is also 1 up to sthana. Now if you are considering 4 sthana, then it means up to 4. If you are considering only 3 places, then in sthana. Sankhya vivedaha nihataihi few ankaihi. That is permutations formed by the numbers. Now let us see. It's a English translation. The product of multiplication of the arithmetical series beginning and increasing by unity and continue to the number of places will be the variations of the number with specific figures. There two things are stated in the verse number 161. First thing is this. What is the next thing? हिंदी में स्थानांत एक अंक के स्थानांतम अंक के स्थान पर्यंत एकादि अंकों का घात करने में संख्या के भेद होते हैं. This is the first thing which is stated in the first of the verse number 161. In the next verse, suppose if 1, 2, 3 are the 3 digits taken and 3 digit numbers, write all the permutation of 3 digits without repetition. Now here there are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. 1, 2, 3, 4, 5, 6. How many permutation of digits will be there? There will be, since there are 3 digits, permutation will be factorial 3. Number of permutations will be factorial 3. Now, number of permutations are factorial 3 if we consider each permutation as a number. If we consider each permutation as a number, that is first permutation 123, 132, 213, what will be the sum of all these numbers? That is stated in the later half of the verse. You read the second part of the verse. Now, we have calculated factorial 3 means factorial n. To know the sum of the numbers found by the permutation of digits, to know the or to find the sum of the numbers found by the permutation of the digits, the formula is factorial n by n. Factorial n by n and sum of the digits. Sum of the digits into write 1 up to the number of places. Now, to do for this example, what is the factorial 3? Factorial 3 is equal to 6. Now, if you without seeing it, without calculating the sum, if you want to buy a formula, then first write down the formula factorial n by n, factorial n by n into sum of the digits, and write in the bracket 111. I think you have understood. Now first one is factorial n by n. Next sum of the digits. Next 10 raised to 0, 10 raised to 1, 10 raised to 2. Because there are only 3 digits. So it will be 100. You calculate it. Verify with the calculator whether it is correct or not. Okay. Verify correct. Is it correct? It should be correct. Next. Now, there are three digits. 10 raised to 0 plus 10 raised to 1 plus 10 raised to 2. Because we are dealing with decimal system. So, in the decimal system, placing 1 in each place will be 111. That is nothing but 10 raised to 0 plus 10 raised to 1 plus 10 raised to 2. Now, verse number 262. Verse number 262. Read the verse. How many variations of number can there be with 2 digits? 8 or 2 and 8, or with 3, 9 and 8, or with the continued series from the 2 to 9. Tell promptly the several sums of these numbers. There in the verse he has given 3 examples. What is the first example? In Hindi. दो 8, 2 and 8, 2 8 और 3, 9 और 8 तथा 2 से लेकर 9 पर्यंत अंकों के क्रम से 2, 3 और 8 अंकों से बनी संख्या के भेद बताओ एवं उन भेदों के अलग 2 योग बताओ. Now we shall take the first example. In the first example, there are only 2 digits. Those digits are 2, 8, and there are only 2 digits 2, 8. How many numbers will form there according to the rule? Factorial 2. Factorial is how much? 2. Which are those numbers formed by 2 and 8? 28 and 82. What is its sum? 110 is the sum. Now we shall calculate it by the formula. What is the formula? N factorial by n into sum of the digits. Which are the digits? 2 plus 8. Next 10 raised to 10 raised to 0. Now factorial is 2 only, factorial 2. There are n digits, that is 2. Now 2 plus 8 is 10. 11. So factorial 2, that is 1. 10 into 11 is equal to 110. So he goes step by step, taking 2 digits only at a time. Next example. Now take 3 digits. 3, 9, 8. You do yourself in it. There are 3 digits. 3, 9 and 8. Factorial 3 by 3 into 3 plus 9 plus 8 into 111. Ah, 4440. All of you have got the answer, right? It seems. Next. Next, example number 2. This is the first example. Next, example number 2. 40. Now, what he says, I have put in the form of formula. But Bhaskaracharya says, for the first example, 2 plus 8 is equal to 10. You write down 10 like this. 10. स्थानांतर एक एक स्थान सरकते हुए by moving one place, you write down this sum. You will get the, when you add it, it will be 110. वैसा जो है ना 398 का. Now first what you have to do, factorial 3 by 3 into 20. उसका पहले निकाल देना. जितना स्थान है उतना स्थान में एक एक स्थान सरकते हुए रख देना, ऐड कर देना. उसके बजाय जो है ना, I have included as multiply by 111. जितना प्लेस है उतना. एक एक प्लेस जब अंका नाम वामतो गति है, उसका मीनिंग जो है ना ऐसा होता है इन द फॉर्म ऑफ फॉर्मूला. That is why I have got factorial 3 by 3 into 20 equal to 40. 40. Leave one place again 40. Leave one place again 40. So if we add it 4 to 40.
So here if we want to do 20 into n minus 1, so here n is 3. So
that is factorial n by factorial n minus 1. N factorial by, now whatever I am doing, factorial n by n means factorial n minus 1. Factorial n minus 1 into sum of the digits. Then that sum is to be placed moving one place to the left. Then add it. It will be the same as the formula which is stated here. Next, third example. In the third example, what we have to do? Take the digits from 2 to 9. 2, 3, 4, 5, 6, 7, 8 and 9. Now, calculate the number of permutations. Then sum of the numbers. Will you take it as a homework? Once we shall show that. It is worked out here. Next. Here. So, how many digits will be there from 2 to 9? 2 to 9. 2 to 9 there will be 8 digits. Therefore, number of permutations will be factorial 8. Factorial 8 means 1 into 2 into 3 into up to 8. So, factorial 8 is equal to this number. What is the sum of the digits from 2 to 9? It is 44. Factorial 8 by number of digits, that is factorial 8 by 8 into 44 is this number. What we have to do? Take this number and place one below the other by moving to the left at a place, one place at a time. So 2 to 1760. So go on. How many times? The number of times of the digits. How many places are there? So many times you have to repeat. So add it. This will be the result. So next.
We are first shifting one place.
Yeah.
Then we can take the second digit and shift another part, the second iteration.
No.
After completing this table, I need to wait for the second digit to shift and make us when we get the same thing.
I could not understand what you are doing.
What I am this we are shifting the first place to the second place of
Yeah.
So we are making this table. So in the next chart, if you make the 10th place number further one more place and make the chart, we will apply the same formula.
Right.
Okay.
So 1, 2, 3, 4, 5, 6, 7, 8. It is this next last one, like ninth line is the sum of all these six. Next. Verse number 263. Be attentive. Now, there is some difference between permutation of digits or permutation of objects when they are different. Given objects when they are different. And if the objects are repeating, for example, take the idol of Vishnu. Take the idol of Vishnu. Shankha, Chakra, Gada, Padma. There are 4 articles. If all the 4 articles to be different in the 4 hands, all the 4 articles in 4 hands should be different, then what will be the number of idols that can be formed? There are 4 articles and 4 hands of Vishnu. पहले इसमें शंख है, चक्र है, गदा है, पद्म है, और शंख इस यहाँ पर आया, गदा यहाँ पर आया, ऐसा एक हाथ में का दूसरा हाथ में ऐसा परमुटेशन कॉम्बिनेशन किए तो कितना मूर्ति बनेगा? फैक्टोरियल 4 बनेगा. समझ में आया? That it is nothing but writing a 4-digit number using digits 1, 2, 3, 4, and one number should not be equal to the other number. Factor 4 हो गया. This is one concept. Taking 4 objects which are different and taking all at a time, ये एक हो गया. Now second concept. हमको पूरा छूट है. अगर चारों हाथों में चक्र रहने दो, चारों हाथों में शंख रहने दो, एक शंख रहने दो, 3 शंख रहने दो, ऐसा बनता है तो कितना मूर्ति बनेगा? वो पहले का जो 24 है, 24, the shapes of the figures of idol with 24 different articles in his hand, that is Keshava, Narayana, Madhava, the 24 names of the Siddhanta. These pictures you can see in Vishnu Kosha. In Vishnu Kosha, all the 24 pictures are there. Next. तो विष्णु को तो बन गया, अब शिव जी को बनना है. शिव जी को बन नहीं सकते, क्योंकि means he has 10 hands. हाँ, वो 10 हाथों में 10 ये है, वो कितना बनेगा? वो जो है ना, it will be factor. अब next concept. अगर विष्णु के ऊपर 2 हाथ में 2 शंख है, नीचे 2 हाथ में 2 चक्र, ऐसा बनाए तो how many different idols will be formed? That means in other case, if 1, 2, 3 and 4 are the 4 digits taken, and any digit may repeat any number of times. That is, the number may be 1111, it may be 4444, it may be 3332, 2222, any number, but there should be a number. So, how many numbers will be formed? It will be 4:4. In other words, number of places and number of digits. Number of digits raised to number of places. That is so many. So, in case of Vishnu, it will be only 256. In case of Shiva, it is 10 raised to 10. हमको एक सहूलत है, कितना चाहिए उतना ले सकते हैं. दत्तात्रेय 3, चतुर्मुख ब्रह्मा, पंचमुख प्राणदेव, षण्मुख, सप्त सूर्य का सप्त घोड़ा, अष्ट दिक्पालक, नवग्रह, ऐसा हम ये दशानन एक कल्पना कर सकते हैं. इसके बजाय instead of this we are teaching there are 4 books, one is Hindi book, other is English book. How many forms you can keep in a shelf, because we are secular. We can't think of gods. वो book चाहिए ऐसा no. While teaching, you will take these examples. Don't worry about secularism. Another concept has to be introduced here. First number 265. After seeing the first 265, we shall go to previous verse. Vinay, come on. Now, if 2 1s and 2 2s, if 2 1s and 2 2s are given, if 2 1s and 2 2s are given, how many numbers will be found? You calculate, you write down. समझ गए ना? 2 1 दिए हैं, 2 2 दिए हैं, 4 नंबर टोटल है. 4 स्थानों में उन 2 डिजिट से कितना नंबर बनता है लिख. There are 2 1s and 2 2s. Form 4 digit number using these things. Totally, only 6 numbers are possible. Then there are repetitions. If all the 4 were different, what would be the number? It is factorial 4. 24 बनता था. Instead of 1 1 2 2, if all the 4 digits are different, that is 1 2 3 4, then the number of numbers found will be 24. Because here 2 numbers are repeating twice. One is repeating twice and 2 is also repeating twice. So their number will be reduced. कैसा इसको निकालना? There are 4 numbers. That's why if there is no repetition, the number of numbers found will be 24. That is factorial 4. Factorial. If all were different, what is the number? It is factorial 4. Now, there are 2 repetitions. So, if there are 2 numbers, how many numbers will be found if they are different? It is factorial 2. These are also 2 numbers. So, their permutation, it is also factorial 2. So, the number of numbers found by repetition will be in the denominator. Total number of digits that can found if they are different in the numerator. That means factorial 4 divided by factorial 2 into factorial 2. हो गया. Instead of that, if there is another number, suppose there are 5 digits. How many digits? There are 5 digits. From the 5 digits, there are 5 digits. How many are repeating? So total number of permutation found will be factorial 5. Among the 3 digits, 2 are repeating twice. That's a factorial 2 into factorial 2. But 5 is not repeating. That's why nothing. So like this way, if there are n digits, and among them one is repeating for p times, other repeating for q times, and the third one repeating for r times, then the number of numbers found will be factorial n by factorial p into factorial q into factorial r. I think you have followed. If there are n numbers where n is greater than 3, if there are n numbers and n greater than 3, and among which one number repeats for p times, other number for q times, and the third number for r times, then number of permutations found will be factorial n by factorial p into factorial q into factorial r. Verse number 64. 264. तो अब जो समझाए वही वो वर्ष में है। यावस्थानेषु तुल्या अंकास्तद्भेदैस्तु पृथक् कृतैः प्राग्भेदा विवृता भेदास्तत्संख्यैक्यं च पूर्ववत्। ये जो आप एक्सप्लेन किए वही जो है ना वो श्लोक है। नहीं verse number 265. Verse number 265. Read it. So there are also two examples in this verse. One is, how many are the numbers with 2, 2, 1 and 1, and tell me quickly, mathematician, their sum, also with 4, 8, 5, 5 and 5. If thou be conversant with the rule of permutation of numbers. हिंदी में संख्या में एक गणक 2, 2, 1 और 1 अंकों की संख्या और उनका योग एवं 4, 8, 5, 5, 5 संख्या के भेद तथा उनका योग बताओ. There are two examples given in this verse. Now, there are 4 digits, among which 2 are repeated twice. In the second example, 1, 2, 3, 4, 5 digits are there, among which 1 is repeating thrice. Now, carry out the calculation. In the first one, in the first example, there are only 4. Therefore, the total factorial 4 divided by factorial into factorial, those 6 numbers are there. Their sum is 6. So, 6 by 4 into 6. Why we have taken 6 here? There are 4 digits. There we have taken factorial n by n. Here we have to not to take factorial n. The number of permutations formed. The number of permutations formed are 6. So, number of permutations formed by the number of digits into sum of the digits. It is equal to 9. Now, place 9 अंकानाम वामतो एक बाजू सरकते हुए बताए तो उसका ऐड करो, वो जो है ना ये नंबर हो जाएगा. You will take down it. Once again, nyasa means given. Given 4 digits, among which 2 are repeating twice. So, total number 4 digits, factorial 4 by the factorial of 2 because 2 is repeating twice, another factor 2 because 1 is repeating also twice. The total number of permutations formed will be 6. Total number of permutations formed by number of digits into sum of the digits is equal to 9. This 9 should be kept one place, moving one place to the left. So add them. So total will be 9 and 10. This is the sum of the numbers formed by all the 6 permutations. Next, okay, second example. Totally there are 5 digits. So, and among which one digit is repeating thrice. So, factorial 5 by factorial 3. Factorial 5 by factorial 3, it is 20. Now, take the sum of the digits. It is 27. Number of permutations divided by the number of digits into sum of the digits, it will be 108. You have to place 108 one below the other in such a way that one moving a place at a time and add them in 5 places because there are 5 digits. 11,999,88. Next, 266. If there are n digits, up till now we have considered the case that in which there are n digits and all of them are taken. There are n digits and all of them are taken. We have, and among which if there are some repetitions, so we have considered 2 cases. First category is that there are n digits and all the n digits are taken. And if all the n digits are different. Second case, n digits, all the n digits are taken, among which some are repeated. Now, we will not consider all of the n digits. If there are n digits, among which we consider only r digits, then how many permutations can be found? That is denoted by NPR. That is permutation of n things taken r at a time. So that will be equal to factorial n by factorial r. Factorial r, factorial n minus r. Factorial n minus r. That means you write n into n minus 1 is equal to n into n minus 1 dash up to n minus r. N minus r plus 1. N minus r plus 1. Next, n minus r minus 1. 1. In the denominator, n minus r minus 1. That up to n. Now, factorial n is n into n minus 1 dash at n minus r plus 1 into n minus r minus 1 up to 1. In the denominator n minus r factor, that is n minus r minus 1, n minus r minus 1, 2, etc. Now cut whole thing with. So what is remaining? n into n minus 1 into n minus 2 up to n minus r plus 1. That's all. This is stated in the next verse. Read that verse. No, 266. That is, starting from n, you should take the product of r digits. This is first one, that is n minus 0. If it is, this can also be written as n minus 0 into n minus 1 into n minus 2 into n minus Is it okay? N minus 0, n minus 1, n minus 2 up to r minus 1. That means 0 to r minus 1 is how much? 0 to r minus 1 is nothing but r. So you have to take the product of numbers starting from 1, starting from n, and r numbers successively decreasing by 1. It is stated like this in the verse. स्थानांतम एका अपचिता एक एक कम करते हुए कितना लेना है? अंतिमांक घातो, that is product. समा अंकैश्च स्मृति प्रभेदा. कितने प्रभेद बनेंगे? कितना प्रभेद बनेंगे बोले तो अंक का संख्या ले लो, उसको एक कम करते जाओ और वो संख्या कितना रहना चाहिए, जितना स्थान है उतना स्थान का लेना. बस. नेक्स्ट. Now verse number 267. Now it's English translation. How many are the variations of numbers with any digits except cipher? That is, cipher is the Persian term used for zero. Arabic and Persian term. Previously, it was shunya in Sanskrit. In the 8th century, it went to Arabas through Brahmasputa Siddhanta translation. It became cipher. Then it has been translated into Hebrew. Then Hebrew again translated the word Brahmasputa Siddhanta, translated again from Hebrew to Latin. There from cipher became Zapram. Then Zapram became zero. And it came back with East India Company as zero. Our Shunya went to the west and came back with East India Company as zero. So Shunya, that is zero. Well, while you are teaching, you should teach that Shunya, that is zero. Not zero, that is Shunya. Cipher exchanged in 6 places of figures. If thou know, declare them. हिंदी में शून्य को छोड़कर 6 स्थानों में स्थित अंकों से संख्या का कितना भेद होगा यह बताओ. Excluding 0. How many digits are there in decimal system? Excluding 0. How many digits are there in the decimal system? 9 digits are there. हमको कितना प्लेस में लेना, कितना डिजिट का नंबर बनना है? 6 डिजिट का बनना है. So what will be the number in terms of notations? NPR means 9PR. 9PR means start from 9, go on reducing by 1. 9 into 8 into 6, you obtain up to 6 numbers. That will be 9 minus 6 plus 1. 9 minus 6 plus 1. Start from 9 and ending up to 4. 9 into 8 into 6, 7 into 6 into 5 into 4. Take the product. That will be the number of the permutations of digits formed. Next. 268.
निरेकमङ्गैर्यमिदं निरेकस्थानान्तमेकापचितं विभक्तं रूपादिस्तन्निहितैः समस्यौ सङ्ख्याविवेकानीतिङ्कयोगे.
So, first take verse number 2.
पञ्चस्थानस्थितैरङ्कैर्यत्ययो वस्त्रयोदश कति भेदा भवेत् संख्या यदि वेत्सि निपत्यताम्.
After solving this example, we shall go to its root. I am teaching from ऐसा खाना भी अच्छा लगेगा. Now, what is in the problem? Form 5-digit numbers so that the sum of digits should be 30. समझ गए? Form 5-digit numbers except 0. Except 0, take all the digits from 1 to 9 and form the 5-digit numbers. You should form the numbers such that this digital sum should be 30. ऐसा कितना नंबर बनेगा? This is the question. Once again, take digits from 1 to 9 and form 5-digit numbers. How many number of numbers will be formed of 5-digit number? For example, take here 11,190 is a 5-digit number. The digital sum is 13. 11,146 is digital sum is also 13. 44,221. Such numbers whose digital sum is 13, how many such numbers can be found? A question here. To answer such types of questions, he has given rule in the previous 2 verses. What we have to do is out. इसका नीचे इसका solution. Now, what is the digital sum? Digital sum is 30. Now, digital sum be yes. Then what we have to do is yes minus 1 by 1, yes minus 2 by 2, yes minus 3 by 3, yes minus 4 by 4. That means yes minus n minus 1. We have to take, this is yes minus 1. There are 5 digits. Deduct up to 1 less than the number of digits. Yes minus 1, yes minus 2, yes minus 3, yes minus 4, not yes minus 5, 1 less than the number. So, yes minus 1 by 1, yes minus 2 by 2, yes minus 3 by 3, yes minus 4 by 4. If you simplify it, you will get the numbers. So, there will be only 495 numbers. There will be only 495 such numbers that can be verified. Yeah. That is verified based on the modern type of calculation. Here there are 5-digit number, among which 4 are repeating. We know how to calculate factorial by number of फैक्टोरियल 5 by नंबर ऑफ रिपीटेशंस फैक्टोरियल 4। ऐसा जो ना ये सभी नंबर में 4 रिपीटेशंस है, यहाँ भी 4 रिपीटेशन है, यहाँ भी 4 रिपीटेशन है, यहाँ भी such type of numbers, their numbers will be 5 because there are 3 such, so their number is 15। ऐसा मॉडर्न मेथड से वर्कआउट करें तो वेरीफाई करें तो OPJ है ना 495 होता है। यहाँ पर कन्नड़ा में लिखे से क्या है, इस तरह का ऑफ दिस टाइप इन इंग्लिश ये लिखने के बाद ऑफ दिस टाइप, दिस इज everyone that's all। No, first number, previous first। अन्य कहाँ इसका अन्वय निकाल, अंक योगे नियते सति, that is if the sum of if the digital sum is fixed one, अंकैक निरेकम, अंक एकम, अंकैक्यम, सम अंकैक्यम निरेकम, that means deducting one एकम कृत्वा निरेक स्थानांतम, एक स्थान कम, निरेक स्थानांतम एकापचितम, एकापचितम, हाँ क्या होना चाहिए यहाँ पर, पा होना चाहिए, एकापचितम का, यहाँ पर का एकापचितम स्थाप्यम। नेक्स्ट इदम रूपादिभिः विभक्तम, रूप मीन्स वन, रूपादि that is 1 2 3 etc, रूपादि विभक्तम तन्निहते, तन्निहते समाः संख्या विभेदाः स्युः, कथितं तु अंकयोगे नवन्वित स्थानक संख्याकायाः ऊने सति वेद्यम। हाँ, here the condition is that in this sentence he prescribes the condition. What is the condition? The sum should be less than the number 9 and number of digits. Yes, should be less than or equal to sum of the digits. That sum of the digits should be less than or equal to 9 plus number of digits. Here number of digits is 5. Number of digits is 5. It should be less than 9 plus 5 is 14. The sum should be less than 14. This formula holds good only in case, this formula holds good only in case where the sum, digital sum is less than 9 plus number of digits. Number of digits is 5. 9 plus 5 is 14. So this holds good for any sum less than 14. So 13 and less. It may be 13, 12, 11, etc. Next. Pune sati vedyam. Prututavayena sankshyiptam uktam. Prututavayam vistarvaya. Yasmat गणितार्णवस्य अतः न अस्ति। गणित अर्णव मीन्स समुद्र। एक गणित एक बहुत बड़ा विशाल सागर है, उसका विस्तार वैसे मैं जो है ना बहुत संक्षिप्त में कहा हूं, ऐसा भास्कराचार्य कहते हैं। Verse number 27 is a एक शिक्षक को बताया है, अगर 271 जो है ना, अगर स्टूडेंट बहुत घमंडी है, मैं बहुत शाना है ऐसा मानते हैं, तो उसको परम्यूटेशन कॉम्बिनेशन का प्रॉब्लम दे दो, उन्हें जो है ना फिसलेगा, बाद में उसको सिखा। न गुणो न हरो न कृतिर न घनः पृष्ठस् तथापि वहां पर दीर्घाना तथापि यस तथापि और दीर्घ होना चाहिए। हाँ यस, हाँ उसको क्या बोलते हैं? अवग्रह। हाँ था के सामने हाँ अवग्रह आना चाहिए। तथापि दुष्टानाम गर्वित गणक बटूनाम, वो बटू का ही उतना ही लागू नहीं होता है, टीचर को भी लागू होता है, और टीचर को बोलना ठीक नहीं रहेगा, उस वास्ते हम बटू को बोलते। बटूनाम स्यात् पातो अवश्यम अंकपाशेस्मिन्, वो जो है ना अवश्य फिसलेगा, ऐसा होता है। यहाँ जो है ना अंकपाश खत्म हो गया। हाँ, ये अंकपाश क्यों कहा है? इस वर्ष से कहा है। पाशा में उर्ल, ये अंकों से उसको बंध किया है। So permutation combination is called technically in Sanskrit by the name अंकपाशा। तो उससे छुड़ाना जो है ना आसान नहीं है, उस वास्ते उसको अंकपाशा कहा। This is all about. Now you see, here we have studied only अंकों का पाश। पिंगला says about लघु गुरु, दोनों को जोड़ सकते हैं। दोनों को जो है ना नारायण पंडित जोड़ा है। शारंग देव जो है ना संगीत शास्त्र और छंद शास्त्र एंड परम्यूटेशन कॉम्बिनेशन उसको जोड़ा है। भरत ने जो है ना नाट्य शास्त्र, सो छंद शास्त्र, संगीत शास्त्र, नाट्य शास्त्र और गणित शास्त्र चारों एक ही है। नाट्य शास्त्र में एक भंगी से दूसरा भंगी को आने को जो टाइम लगता है, उतना संगीत शास्त्र में आलाप रहेगा, छंद शास्त्र में उतना मात्रा रहेगा, गणित शास्त्र में उतना टाइम रहेगा। So I have combined mathematics and छंद शास्त्र. Those who know संगीत शास्त्र and नाट्य शास्त्र take Bharata's नाट्य शास्त्र and Sharangadeya's संगीत शास्त्र, combine them. Combine छंद शास्त्र and which one? Sangeeta, Natya, Chandas and mathematics. One who knows Sangeeta combines Sangeeta with mathematics. So permutation combination, how much they will be taking? 2 at a time among 4. So 4C2. What is 4C2? How much it will be 4C2? 4 into 3 by 1 into 2. So there can be 6 PhDs. There can be 6 PhDs connecting one Shastra with the other. Any questions regarding this session? Now how research work is to be done? This is our question. Such things I like very much. हमको क्या मालूम है? अगर डिजिटल सम दिए है, नंबर ऑफ डिजिट्स दिए है, तो वैसा कितना परम्यूटेशन बनेगा, इस भास्कराचार्य ने कह दिया है। Now we shall extend this notion of permutation and combination to theory of probability. कैसा एक्सटेंड कर सकते हैं? Now there are 5 digit numbers and number of digits are from 1 to 9. So take dices of 9 faces. Dice means मालूम है ना दाड़. So take 9 face dices of 9 face. Take 5 dices. Write on them on each face from 1 to 9 digits. There are 9 faces. On the faces of dice, write from digits from 1 to 9. Take 5 digits simultaneously and throw them. Then there will be some numbers on the upper face of the 5 dices. Their sum, how many chances will be there getting 13 on the upper face? नहीं समझ पाए? 5 दाढ़ है, वो दाढ़ों के ऊपर एक फेस पर एक, दूसरा फेस पर 2, ऐसा 9 फेस पर 9 अंक लिखे. वो पांचों फांसा जो है ना फेंके, फांसा फेंकने के बाद जो है ना ऊपर का फेस में जो अंक रहते हैं उनको जोड़ दिए तो उसका सम जो है ना 13 होना. वैसा कितना चांसेस होगा? That is number of permutations. We know, we have calculated their number is 495. What will be the equally likely cases in the terms of statistics? कुल जितना होगा irrespective of the sum, कुल संख्या कितना रहेगा? That will be 9 raised to 9. टोटल संख्या जो है ना, टोटल संख्या जो है ना P will be 9 raised to 9. 9 raised to हाँ, टोटल संख्या 9 raised to 9 रहेगा. क्यों बोले तो there are 9 digits. 9 raised to 9 रहेगा. So what is the probability of getting 13 as the sum? What is the probability of getting 13 as the sum? It is 495 by 9 raised to 9. So we have extended the concept of sum of the digits stated by Bhaskaracharya to the theory of probability. ऐसा कौन सा क्या कहाँ क्या extend करते हैं ऐसा देखना. A very good paper on this by R.C. Gupta. Last problem in Lilavati. ऐसा आपने लिखे अच्छा एक name. So while studying any chapter, what is the possibility of further research? ये जो है ना research scholar को ध्यान में रखना चाहिए. And how this can be connected with arth sum. Write down 1, 2, 3, 4, 5. Next 1, 3, 6, etc. Next 1, 4. Why procedure? Next. These are the natural numbers. This is the first sum of natural numbers. This is the second sum of natural numbers. This is the third sum of natural numbers. So, rth sum of natural numbers. So, ऐसा to know the rth sum of natural number up to certain number will be obtained by the formula s minus 1 into s minus 2 into s minus 3 into s minus 4 by 1 into 2 into 3 into 4. So, concept of rth sum. Where this can be used? Narayana problem. A very interesting problem. I think I have told already.
Yes,
mentioned. सिस्टम में भी है. वो प्रॉब्लम क्या है? कन्यादान के साथ गोदान भी किए थे. 20 साल के बाद वो कामधेनु का प्लान का था हर एक साल एक she calf. The she calf after attaining 3 years it will also give starting calves every year, one calf every year. In 20 years what is the progeny? So first question, this is a simple question. Next जो है ना, अगर आप आगे भी करना है तो कौन सा एज का कितना है. First total progeny irrespective of their age. If you are able to solve this one, the next question will be what is the number of calves and number of cows according to their age. A cow gives birth to one calf every year. The calves become young and themselves begin giving birth to calves when they are 3 years old. O learned man, tell me the number of progeny produced during 20 years by one cow. Here, the concept of Meru Prastara. Narayana Pandita obtained this from Meru Prastara. So, literary people should not say, oh, we don't know mathematics. What is the mathematics in Meru Prastara? And what the number of in each cell of the Meru Prastara, what it signifies for? R plus 2th cell of n plus r plus 1th row of a Meru Prastara gives this rth sum of a number. वो ऊपर से चलेगा. Now 1, 2, 3. Now first of all 20 years. It means the first calf. How much the first calf gives? The cow gives 20 calves. The first calf gives starting calves at the age of 3. So first calf will give only 7. Second calf 60. Third calf. So like that one, that is to be calculated. This is the first sum, second sum, third sum, fourth sum, fifth sum, sixth sum. You have to deduct 3. 20 minus 3, 17. 17 minus 3, 14. 14 minus 3, 11. 11 minus 3, 8. 8 minus 3, 5. 5 minus 3, 2. A 2-year calf cannot give further calves. That's why we stop there. Next. They are denoted in mathematical terms. So, for only mathematicians, this one. It is denoted by NVM. Rth sum of a natural number n is equal to n plus r c r plus 1. Combination of n plus r things taken r plus 1 at a time. Therefore, the r sum can be obtained from the r plus 2th cell of n plus r plus 1th row of Meru Prastara. Meru Prastara सामने लाना. First row, second row, third row. So n plus 1th row, first cell, second cell, like that one. R plus 2th cell in n plus r plus 1th row gives the rth sum of n. वहां से वो निकालना चाहिए. There are two ways of calculating this. One using Meru Prastara, other which we have stated now. So that n plus r n plus r c r plus 1 is nothing but it can become first sum is equal to n into n plus 1 by 1 into 2. You have learned that one. This one in arithmetic progression. In arithmetic progression, that is Sankalita. N into n plus 1 by 1 into 2. This also you have learned. This is sum of natural numbers. This is sum of triangular numbers. So, ये दो फार्मूला जो है ना आप सीखे सो है. This was for the particular case. This is first sum. Second sum. Extend the concept to the rth. Next. वो solution बता देंगे बस. So total number will be so this is the original cow given in Godana. It gives 20 calves. The generation belonging to the first calf, second calf, etc., they give 17 V1. The third generation, fourth generation, fifth generation, ऐसा इस सबको अगर मिलाए तो answer will be 2745. From one cow in 20 years, the progeny is 2745. अब हम जो है ना बहुत फॉरवर्ड हो गए हैं, पिंक रेवोल्यूशन कर रहे हैं, व्हाइट रेवोल्यूशन तो चले गया. Pink, do you know what is pink revolution? This is out of context. Pink revolution means exporting the flesh of the cow. That is pink revolution because its color is pink. So it is regrettable. ठीक है. तो यहाँ पर हम विराम लेंगे. Now in the introductory class we have seen that whatever is nearer to nature survives and whatever is far from nature perishes. While raining, you should have observed what is the shape of raindrops. What is the shape of raindrops? Spherical. Sphere. Why? Because mathematically minimum surface with maximum volume. Sphere is a three-dimensional figure or three-dimensional entity which contains maximum volume in minimum surface. That's why raindrops will be spherical. Suppose if the roof is leaking and drop by drop water is falling on the floor, let us assume the floor is flat. Then what shape after the drop by drop water will attain? Then water is pouring from the roof to floor and water will spread. In what shape the water will spread? It will be circle. Why? Mathematically, circle is a two-dimensional figure which contains maximum area with minimum perimeter. That's why a liquid will form a circle. If we consider particles, matter consisting of small particles, and if that material is poured on the flat surface, that particles having no cohesive force, what shape it will attain? समझ गए? If some matter consisting of small particles such as grains, एक थैली राइस हम एक फ्लैट सरफेस पर pour के, what will be its shape? हो जाए ना? It will be in the shape of a cone or heap. Such heap of particles in Sanskrit is called as rashi. Jolad rashi aite no, bhattu rashi aite no. So that conical shape, heap of conical shape of grain or sand, etc. is called as rashi. If it is put on a plain ground, then it will be of a conical shape. If the heap is towards the side of a wall, if it is towards side of a wall, what will be its shape? What will be its shape? Padmana. if the Rashi is put against a wall, then it will be half of the cone. If it is put in a corner, 1/4 of a cone. If it is put outside the corner, 3/4 of it. Now one chapter is over. Rashi Vyavahar is over. Now, in engineering terms or technical terms, dry cone. Dry cone so that its height is very less compared to its diameter. Dry cone such that its height is very less than compared to its diameter. Now rub this first figure. Draw the diameter. Now here, in engineering terms, this is a plane that is tala. We will call in Sanskrit also tala. A circular surface, curved surface. The angle formed by the curved surface with the base, if it is denoted by the Greek letter theta, in engineering terms, it is called as angle of repose. If wet sand is there, if wet sand is there, whether the angle will be greater or smaller compared to dry sand. If the sand is dry, this angle theta will be compared to greater. In case of grains, if grains is of small corns, say jawar, sasni, mustard. If it is of mustard, if you take different corns, the angle of repose will vary. So, and concept of angle is from the West. Now, in how we stated this concept, now we shall denote its height by h. Let h be the height, and let c be the circumference. C by some constant is equal to h. C by some constant is h. This constant was taken depending on the size of the grain. Shukadhanya means those having a cap. Now, कन्नड़ದಲ್ಲಿ ಅದಕ್ಕೆ सुंक ಅಂತ ಹೇಳ್ತೇವೆ. हाँ, आपके जवार उसको जो है ना पहले क्या रहेगा, उसके ऊपर एक कैप रहेगा. हाँ, उसको इन संस्कृत it is called as shukadhanya. Because we take a different constant. Suppose c by 9 is the height of a rashi of bigger rashi of corns of bigger size. If the size of the corn goes on decreasing, then k goes on increasing. With this concept, we shall look after the verse number 227. Read the
अननुषदशमांशोऽनुष्वतैकादशांशः परिधिनवमभागशोकधान्येषु वेधः भवति परिधिषष्टे वर्गिते वेधनिघ्ने गणगणितकरासुर्मा
line by line, richa by richa. Ananu, anu means small one. Ananu means bigger one. Ananushu dashamamshu. Dashamamshu means 1/10. What is it is 1/10? Dashamamshu anushva atha ekadashamshaha. Ananushu dashamamshaha. Anushu ekadashamshaha. That means for bigger cars of bigger size, heap of cars of bigger size, K is taken as 10 for Ananushu. For Anushu it is 11. For Shukadhanya it is 9. Ananushu dashamamsho, Anushu ka ekadashamshaha, paridhi navabhagaha, that is paridhi navabhagaha, paridhi navabhagaha, Shukadhanyashu, what? Vedha, Vedha means height. Height of the heap will be 1/10 of the circumference in case of heap of dhanya, where the cords of dhanya are bigger in size. If they are smaller in size, then the height of the rashi will be 1/11 the circumference of the rashi. If the rashi is of Shuka Dhanya, then height of the rashi will be 1/9 of the circumference. This is stated in the first two lines. Next, what is stated in the next two lines? A sixth of the circumference being squared and multiplied by the depth, the product will be the solid cubits, and they are kharis of Magada. Now, khari is the unit of measure of capacity. Now, what we have to do? Equation. It is next verse. I will write. A sixth of come here. C by 6 square, C by 6 square multiplied by H is equal to V. Now, how we have to calculate the volume of the heap? We have to calculate volume of the heap by C. No, C by 6 whole square. C by 6 whole square into H is equal to V. By knowing C, we will be able to calculate its volume, because by knowing C, by knowing the type of grain, we can calculate H. We know C and H. Using the formula, we can calculate the volume of the rashi. Is it okay? Now, so again to the verse. Uttarardha of the verse. Verse number 227. Bhavati paridhi shashte. Paridhi shashte vargite vedhe nighne vedha nighne Ghana Ganita Karaha. Ghana Ganita Karaha means hasta. That is Ghana hasta. The volume will be measured in Ghana hasta. Ghana Ganita Karaha Syu Margas Magadas Tascha Kharyaha. That Ghana hasta is called as Khari in Magadha. In Magadha Desha, that one Ganahasta is called as Khari. Next verse. Anyone can read it.
समभूतिलराशिर्यस्थितस्थूलस्थूलधान्यः परिधिपरिमितस्याधस्तषष्टिर्जलीया प्रवदगणकस्वार्यः किंविदा सन्ति तस्मिन् अथ ततगुणगणधान्येषु कथान्यश्च शीघ्रम्.
There are only two formulas. First formula is H is equal to C by K. Or there are three cases. First case, when it is ananu. In case of ananu, K is equal to 10. In case of anu, 11. In Shukadana, it is 9. So, using three equations, we have to calculate first H. By knowing C and calculating H, we have to calculate the volume. V is equal to C by 6. K is equal to 9. K is equal to 9. Now, in this example, now given thing is that circumference of the Rashi is 60 hasta. Calculate its volume in all the three cases. C is equal to 60. You have to calculate the volume of the Rashi in the three cases. First find H using C by K is equal to H. And then find out V using C by 6 whole square into H. I think you will be able to do it. It is very, very easy. Next. Shall we proceed? So, now I will ask this question. If C is the circumference of a heap put in the middle of a room, then it will be completely C. If it is put against the wall, then what will be the circumference of the heap? C by 2. If in a corner, it is C by 4. If it is outside the corner, it is 3 by 4C. So, first, if C is given, complete circumference is to be found out. If it is against a wall, then what is the complete circumference? Given C into 2. Then we shall not call it actually as C, we shall call it as P. That is perimeter of the Rashi. If P be the perimeter of the Rashi against a wall, if P be the perimeter of the Rashi against a wall, then P will be equal to half C. Where C will be the Purna Rashi. Then if P is the perimeter of the Rashi in a corner, then P will be equal to 1/4 of C. What is C? 4P is C. P is 1/4 of C and C will be 4 times P. If P is half C, then C will be 2 times P. Likewise, if it is outside, then what is C with respect to P? It is 4 by C P. 4 by 3 P. So, given perimeter, first of all we should arrive at C. That is circumference in case it is a complete cone. Then find out its volume. Then again divide by the coefficient. If it is against a wall, if it is against a wall, it will be half of V. Calculator V, if capital V is the volume, calculate for the complete Rashi. Rashi against the wall will be half of the volume of the complete Rashi. If it is sitting in a corner, then it will be 1/4 of the Purna Rashi. If it is outside the corner, it will be 3/4 of the Purna Rashi. Next.
परिधिर्भित्तिलग्नस्य राशेस्त्रिंशत्करः अन्तकोणस्थितस्यापि इति तुल्यकरस्सखे बहिष्कोणस्थितस्यापि पञ्चघ्नन्नवसंमितः तेषामाचक्ष्वमे क्षिप्रं घनहस्तान् पृथक् पृथक्.
Now, the perimeter of the Rashi put against the wall is 30. So, what is the circumference of the Purna Rashi? 30 multiplied by 2, it will be 60 hasta. Trimshat karaha against bhitti means what? Antah konaha in a corner. Antah kona stita kona stita syape tithi. How many tithis are there? There are 15 tithis. So, the perimeter of the Rashi put inside a corner is 15. So, what is the circumference of the whole Rashi? 15 into 4. It is again 60 hasta. If it is outside, what is there? Baish konasita panchagna nava. Panchagna nava. Multiply 9 by 5. How much it is? 45. 45 hasta. So, what is the circumference of the Purna Rashi? 45 into 4 by 3. So, 3 into 15, 45. So, 15 into 4, again 60. Next. Complete. 1 minute. It is like this. If it is against a hasta, half paridhi. If it is in a corner, 1/4 paridhi. If it is outside the corner, that is 3/4 paridhi. And next. 60 hasta, 60 hasta, 60 hasta. Now make a table. Sthula dhanya, Sukshma dhanya and Shuka dhanya. What you have to do? Find H. In case of Sthula dhanya, it is 60 by 10. In case of Sukshma dhanya, it is 60 by 11. Because 10, case 10 in case of Sthula dhanya. In Sukshma dhanya, it is 11. In Shuka dhanya, it is 9. So, C by 6 whole square into H into half because it is against the wall into 1/4 because it is in a corner, inside corner into 3/4 because it is in a outside the corner. That's all. I think everyone has understood. Any doubts? So, this chapter is already completed. This chapter is already completed before taking the examples. So, examples are taken to make it more clear. Verse number 220. Verse number 220. Now, these are all formulas stated for practical purposes. Instead of material consisting of small particles, if they are solids, that is like stones or bricks, then what can be done? They can be put one on the other. If they are bricks or stones of regular size, then heat is not to be done. राशि जो है ना एक ढेर नहीं डाल सकते, उसको एक सिस्टमेटिक एक के ऊपर एक रख सकते हैं. एक के ऊपर एक रखे तो वो क्या बनेगा फिगर? The figure will be usually a parallelepiped. उसका वॉल्यूम क्या रहेगा? बेस वॉल्यूम क्या रहता है, उसका हाइट से मल्टीप्लाई करते तो उसका वॉल्यूम होगा. अगर if the usually bricks will be of uniform size, तो उसका हाइट क्या रहेगा? हाइट फिक्स्ड रहेगा. टोटल हाइट उस स्टैक का टोटल हाइट को हाइट ऑफ द ब्रिक्स के भाग दिए तो क्या आएगा? नंबर ऑफ लेयर्स आएगा. सो एरिया को ब्रिक का एरिया से भाग दिए तो क्या होगा? एक लेयर में नंबर ऑफ ब्रिक्स आएगा इनटू नंबर ऑफ लेयर्स विल बी द टोटल नंबर ऑफ ब्रिक्स. नहीं तो बड़ा स्टैक जो है उसका वॉल्यूम लेंगे, एक ब्रिक का वॉल्यूम लेंगे, बड़ा वॉल्यूम को एक ब्रिक का वॉल्यूम से भाग दिए तो क्या आएगा? नंबर ऑफ. सो अदर चैप्टर इज ओवर. Now चिति means stack in English. एक के ऊपर एक रखने का. Now these are solids. They will not spread like liquids or grains without cohesive force. So उसको जो है ना एक नियत आकृति पे हम जो है ना स्टैक कर सकते हैं. तो उसका वॉल्यूम कैसा निकालना? लंबाई बाई चौड़ाई और उसका हाइट, वो कंप्लीट वॉल्यूम आ जाएगा. उतने उसमें कितना ब्रिक्स है, एक ब्रिक का वॉल्यूम लेना और टोटल वॉल्यूम को उससे भाग देना, नंबर ऑफ ब्रिक्स आ गए. अगर एक ब्रिक का साइज जो ना हाइट कितना है, उससे टोटल हाइट को भाग दे तो क्या आएगा? नंबर ऑफ लेयर्स पर आ जाएगा. इतना ही है. तो एक चैप्टर खत्म हुआ. और एक चिति व्यवहार. Shall we go in detail? Only this is the content. So, is V is equal to A into H. N is equal to V by V. L, that is number of layers, is equal to capital H by H. Ananta Padmanabh. L, what is A and what is H? V is equal to A into H.
A is the area.
You stood up because you are a student.
A is the area of the
Stack.
area of the stack.
Because it is capital A.
X is the height, total height of the stack. Is the volume. N is the number of bricks. Equal to volume of the full stack by volume of one brick.
Is the total number of bricks?
L is the length of
number of layers.
Number of layers. Total height divided by height of one brick.
So next, scrolling. Now L, B, D are given. Length, breadth and depth. L into B will give the area. D or H, one and the same. Either it can be called as depth or height. Usually when in a digging, it is called as depth. When it is above the ground, it is called as height. V equal to L, B, H. This is big V. Small v is the volume of a brick. Capital V, small v is the number of bricks. H by H is the number of layers. Next.
So it's we note the question alone. Okay.
Next. Shall I stop here? You may continue. No, not this one. Any other topic. Now 2 chapters are complete. You continue the class. Because some of them feeling somewhat आप कंटिन्यू करो फिर रेस्ट लेने के बाद मैं
I will just put this question. Give me 5 minutes and then we will, so that I can connect to this. This you want to take it down, right?
So आधा घंटे में 2 चैप्टर्स खत्म हो.
This one. Ah, yes. Next verse.